Guys, today what we're going to be doing is finishing off the prime factorization and bringing in the concept of exponents. This is very vocabulary heavy. You need to understand these definitions. So please have them written down because, again, you're probably going to be seeing this on our next test. When we talk about exponents, most of the time you think of this entire picture as an exponent, but it's not. This whole thing is actually called a power. Okay? So what you normally think of as exponent, we actually are thinking of as a power. Now, the power is made up of two pieces. The first piece is the number that is being multiplied by itself. That is the bigger number, or in this case, the 2. The math term for that is the base. So the base tells me which number it is that I am multiplying. The exponent itself is this superscript number, the little one up top. So this is what is actually the exponent. Now, when I'm looking at a power, and I actually want to read it, how I would say this in English is, I would say 2 to the 5th power. Or I could just abbreviate and say 2 to the 5th. The power is assumed, because when you're doing an exponent, it has to be written as a power. So those are your primary terms when we're talking about exponents. Madison? No. No, I said 2 to the 5th power. And that's why it's important you add that to the. So 2/5 is totally different than 2 to the 5th power. Okay? And we'll see this in just a second. So now that we've got that piece down, let's talk a little bit more about it. If I'm actually writing a power and talking about them, if I were to say 3 to the 1st power, how would I actually write that power? Emma?
3 would be your base. And
Good.
1 would be your exponent.
Good. So I have a big 3 as my base and a little 1 as my exponent. That is the power. Now the factors is, what is it that I am actually multiplying? So in this case, how many 3's do I actually have? I only have 1 3, so it's just 3. That is all I would have to write. Okay? Now, as we get to the next one, now we're going to introduce a couple of more math terms. The first one, 3 to the 2nd power, or 3 squared. So if I use the term squared, that means to the 2nd power. By definition. So anytime I see something squared, so example, 5 squared, I would write as 5 to the 2nd power. Make sense? So if I have 3 to the 2nd power, or 3 squared, to actually write it, I write a big 3 with a superscript 2, a little 2 to the top. What are the powers? How do I write the factors of 3 squared then? 3 squared would be the same as what?
Oh, 3 with 3 to the 1st power.
No.
3 times 3.
3 times 3, it would equal 9. So 3 times 3 is how I would write the factors. Okay, another special term is cubed. So cubed, by definition, means to the 3rd power, or an exponent of 3. So for example, it would be 5 to the 3rd power. I put a 3 there. That is what cubed means. So if I see the term squared, that means to the 2nd power. If I see the term cubed, that means to the 3rd power. To write it, I would go 3 to the 3rd power. And my factors would be 3 times 3 times 3. Now, once we get past the 3rd power, we don't have any other special math terms for them. So now it's just going to be saying to the whatever power. So if I have 3 to the 4th power, it's going to be 3 to the 4th. Writing it as a product of factors is 3 times 3 times 3 times 3. This is making sense. Are you guys understanding this concept so far? Madison?
What does that say?
Which one? Squared to the 2nd power. Cubed. Cubed. C-U-B-E-D. C-U-B-E-D. Cubed. I also circuited it on the word chart. Cubed. Okay? Okay, so let's keep talking about the vocabulary. We've already talked about it, but now we're putting it side by side for you. And a number expressed using exponents, what would we call that? The power. Okay? So the power. Okay? The example we've been using, we'll say, is 5 to the 2nd power. The whole thing is a power. Okay? The number used as a factor, in other words, the number I'm multiplying by itself, what was the term we used for that one? The base. Okay? In our example, 5 to the 2nd power, 5 is our base. How many times the base is used as a factor, that is what we call the exponent. So even though that's kind of the title of the lesson, it's really just that little number. So again, in our example, 5 to the 2nd power, the 2 is our exponent. Now here's one we haven't talked about yet, but numbers that are square of whole numbers. In other words, when I multiply a whole number by itself, that answer is what we call a perfect square. So for example, what we've been using, 5 squared equals, what's 5 times 5? 25. So 25 is said to be the perfect square of 5. So 25, whatever number I get, so some other perfect squares are numbers like 9, because that's 3 times 3. 16, because that's 4 times 4. Make sense? No. What does that 2 tell us, Madison? What does that 2 tell us? By itself. So 5 times 5. That is the most common mistake. But we have to crush that right now because I don't want you guys making that mistake. And then expressions with the same value. We've actually had this term many times already. What do I call expressions that have the same term? Or same value? Maddie? Oh. What? Equivalent expressions. Good. Oh, okay. So these are called equivalent expressions. Okay? So those are equivalent expressions.
You leave that for a second.
I was going to move it up.
Thank you.
And then expressions with the same value. So for example, 5 squared, an equivalent expression would be 5 times 5. Those are equivalent expressions. Yes, ma'am? Okay. So any questions? This has all been basically vocabulary so far. Any questions on the vocabulary that we have covered? Yeah, they did.
Can I point to the board real quick?
Sure.
Okay, so, like, but it's that's like 3 to the 2nd power of, oh, this is or, sorry, I thought it said 3 to the 2nd power of 3. I thought it meant, like, it wanted us to, like, multiply 3 times by itself.
I'm glad you reread it and understood it.
Yeah.
Okay, so let's talk about actually doing this now. So I'll leave it there so those of you that got it late can catch up. You can cross out the D. It's supposed to be generate an equivalent expression. So basically all we're doing is we have given these to you in what we call expanded form. So expanded is when I write out all the numbers that I'm multiplying. And we're now asking you to write this in exponential form, which is written as a power. So how would I rewrite 6 times 6 times 6 times 6 in exponential form? Rosena? 6 to the power of 4. Make sense? Okay, you have 1 minute to finish the other 6. So I have 9 to the 7th power. Now, number 5 is where it got a little trickier because we threw 2 different numbers, but that's just 2 to the 3rd power times 3 to the 3rd power. Guys, quiet down. Number 6 is 8 to the 4th power. And number 7 is 5 to the 5th power times 3 to the 3rd power. I know. Oh, I did use the X. Goodness gracious. Thank you, Aaron, for calling me out in public. I did it again. Woo! Mr. Moore's having a day. Personally, I blame Miss McSham, but that's okay. Guys, listen up. Guys, Cannon, put it away. Guys, listen up. Okay, right now we're going to actually combine what we did last class with finding the prime factorization and what we're doing today with writing them as exponents. Okay, so we're still going to do the same we did yesterday. Again, it doesn't matter if you use the cake or if you use prime factor trees. I will re-emphasize one major difference when you're using cake with prime factorization versus GCF LCM is I cannot take out numbers that are not prime. You have to go through your orders, 2, 3, 5, and 7, if you want to use the cake. Otherwise, you're going to mess up. Okay? But if you do it, it's actually really easy because I just started at 90. Can I divide that by 2? Yeah, 45. Can I divide by 2? Nope. 3? Yeah, 4 plus 5 is 9, so I know I can divide it by 3. That's 15. 15, I can divide by 3, gives me a 5. So here's where we're going to combine those two. How many 2's do I have? 1. How many 3's do I have? 2. How many 5's do I have? 1. And that is my prime factorization. Remember, guys, this right here, that is just how we find the prime factorization. The prime factorization is when we actually rewrite that as a multiplication sentence. So your answer for prime factorization is when you rewrite that. You can't just have the work. Okay, we'll give you guys 4 minutes to finish up numbers 2 and 3. If you finish those, go ahead and continue down to 4, 5, 6, 4, 5, and 6. Okay, thanks to those who caught this. I skipped the bottom of this page. So, listen up. There's 2 parts to this. Express each power as a product of the same factor. In other words, take the exponent, rewrite it as a multiplication expression, then determine the value. What does that mean? Solve it. So there's 2 pieces to this. Rewrite it as a product of the factor, then solve it. Then you're also going to do the other parts. We'll give you guys an extra 3 minutes. We'll make it 5 total. So you have 5 minutes. Finish 1, 2, 3, 2, 3 here, and then as much of the rest as you can. Go. So my first one, I rewrite 5 squared as 5 times 5, which equals, Micah? Our first one equals?
5 times 5?
That's what we rewrote it as.
25.
What did you write on your paper? What's the answer on your paper?
What even are you talking to? You asked me what 5 times 5 was.
No, I asked you what you wrote on your paper.
Oh, this side? Oh.
Yeah.
No, you're talking about number 1, right?
Right, number 1. What's your answer? What did you write on your paper?
I mean, it was 10, but it was 5 with power 2, right?
No. Multiplying 5 by itself. Guys, listen up. Okay, so I kind of picked on Micah because I saw that he had done that. But that is the most common error on exponents. Please, 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 I'm begging you. Listen to this because this is important. When you see an exponent, rewrite it as a multiplication so you don't do what Micah just did. Because it's 5 squared, 5 times 2? No, it is 5 times 5. 5 times 5 is 25. Okay? And if you write it out and pay attention to it, you're much more likely to realize that it equals 25. Go ahead. Now, that being said, what does my next one equal? How would I write it out? Andrew. Thank you. 15 times 15 times 15. Now, that one multiplied out actually equals 3,175. 300, yeah, it is. 3,375. My bad. 3,375.
Why are you doing talking? Thank you.
So what this was, 15 times 15 is 225. You multiply that by 15. Gives us 25, 12, 11. The 0 goes down, 5, 2, 2. So we add up our columns, 5, 7, 3, 3. 3,375. Okay? Our last one, how would I rewrite that one, Mateo? Number 4, or number 3, sorry. Good, I do 4 sevens. So then, I'm going to do this the way I would, which is I can combine the 7s and just make it 49 times 49. 49 times 49, I do the 9 times 9 is 81, 36, 44, 0, 36, 16, 19, 1, 0, 2,401. Yes, Micah.
This isn't about the math, but it's just a question because I'm stuck on it. Should I keep my curly here or should I get my dreads in?
Curly.
Curly?
Yeah. Okay, next one. So again, you can do factor tree or cake. It doesn't matter. You should get to the same answer. I'm going to use the cake because to me it's faster, and I know I can only use 2, 3, 5, and 7. So that gives me a 72. 2 gives me 36. 2 gives me 18. 2 gives me 9. 3 ends at 3. So I have 4 3s, so 2 to the 4th power. Or 4 2s and 2 3s. Do what? That's fine, but your answer needs to be the same. If you have a different answer than that, then you did it wrong. I'll let Mrs. McShann look at it. Okay, 500. Same concept. I can divide that by 2, gives me 250. Divide that one by 2, gives me 125. Divide that one by 5, gives me 25. Divide that one by 5, gets me a 5. So 2 to the 2nd power times 5 to the 3rd power. Make sense? Questions on those? Can you see how the 2, 3, 5, 7 can make this really fast for you? Key is you got to use only those 4 numbers. Our next one, prime factorization of 48. So this one, I start at 48. I can go by 2, gets me 24. 2 gets me 12. 2 gets me 6. 2 gets me 3. So I have 4 2s and a 3. That would be answer A. Our next one, I have 2 3s and 3 4s. So 2 3s, 3 4s, that's answer C. And then our prime factorization for 84. So 84, and actually this one don't even need to, no. If I look at the answers, 6 is composite, 22 is composite, 4 is composite. They only gave me one possible answer.
With prime number.
even though they did it backwards. So that's one you got to be careful of. Okay? And the next part, ooh, this actually worked out almost perfect. We have 15 minutes, and we have 17 till lunch. Yep. Okay, so the next part is yours to work with your partners. You're doing number 1 at the bottom of the page, and then you're doing the entire next page. Guys, listen up.
Guys,
Micah?
listen, please.
Yes, Aaron.
Let me quit humming and doing whatever else noise you're making.
Excuse me, yeah, just a minute. Okay, I need to write this out. When we say product of the same factor, that's saying write it out with how many times I'm multiplying that number by itself, then determine the value. In other words, solve it. So you're doing 2 parts on those 3 numbers. Okay? The next one, you're just factoring the following using exponents. The rest of them should be very easy. You have 15 minutes, go. Okay, let's go over the answers. I am going to go quickly because you guys should have the answers. So we're just finding out which ones are correct. So you're basically just doing self-check, but you don't have to have a pen out. You can use your pencils. Number 1, I need a prime factorization. Is it possible to have a composite number if it's a prime factorization? No. So that's got a 12, that's got an 8, that's got a 6. None of those work. It has to be B. Okay? It has to be B. Okay, prime factorization for 90. If I start at 90, I can divide that by 2 is 45. 3 is 15. Guys, please stop talking. 3 is 5, so I have 2 times 3 to the second power times 5. 2, 3 to the second power 5 is answer C. Number 3, expression of 5 to the third power. So that's 5 times 5 times 5. It may help you to write this out. Times 5. Yes.
This is 2 to the 3, 2. This is 3, 3.
Oh, thank you. It was B. I went too quickly. Okay, number 3, 5 to the third power. Please stop the chatter, guys. If you have a question, raise your hand.
Were you about to say yeah?
Kaylee, that means don't talk. So 5 times 5 is 25. 25 times 5 is 125. 125 times 3 gets me 375. Another way of expressing the 4 to the 4th. So that means our 2 to the 4th, I need 2 4s there, 3 4s there. So I need the one with 5 4s, which is answer C. Prime factorization of 176. I don't have anything I can get rid of. They have all prime numbers. So I need to actually do the math on this one. 176 divided by 2 gives me 88. 2 gives me 44. 2 gives me 22. Gives me 22. 2 gives me 11. So I have 4 2s and an 11. 2 to the 4th times 11 is answer D. Now, there are 2 parts to the next ones. Make sure you're doing both parts. So I have to express as a product. That means that is 4 times 4. And evaluate, that means it is 16. Our next one, 9 times 9 times 9. 81 times 9 gives us 729. Our next one, we write it, 11 times 11 times 11 times 11. So for me, I'm going to go 121 times 121. Gives me 121, 0, 2, 4, 2, 0, 0, 121. Gives us 1, 4, 6, 4, 1, 14,641. Now we're doing a factoring. So we're going to factor these back again. So starting at 256. Let's try that again. 256, I can divide that by 2. Gives me 128. Divide by 2. Gives me 64. Divide by 2. 2. gives me 32 divided by 2 gives me 16 divided by 2 gives me 8 divided by 2 gives me 4 divided by 2 gives me 2. So I end up 1, 2, 3, 4, 5, 6, 7, 8 2's, 2 to the 8th power. 121. This is one that can mess you up on my 2357 because 121 is the next number that is a product of a perfect square. 11 times 11. So 11 to the 2nd power. 99. Can't divide that by 2, but I can by 3. Gives me 33. Can still divide that one by 3. Gives me 11. 11's my next key number. So 3 squared times 11. Any questions on that page? Quick thumb meter, how did we do? Hold it high. See how did you guys do? Okay, I have a lot of middles. That's not so good. Well done, Micah. Okay. If you go to the back page, that is your homework for tonight. No big ones on this. Guys, please listen. Yes. There is a joke in there. It's a good dad joke again. So make sure you are showing your work, though. A lot of these I know you can do mentally, but write down so we can see that you understand what you are doing. So make sure you're showing your work. Go ahead and open up your modules to page 14. Your new modules. Open them up to page 14.
Where's my opening exercise?
Open your module to page 14.
Shush. Don't say anything.
I'm sorry, Kaylee. It's on the board, and I've said it 3 times.
Don't say anything.
Yes?
So when I get home, I have a bunch of cardboard boxes. Ever since I just got my shoes, I'm gonna take them, I'm gonna mold the shape of the shoe, and then that way when I walk, my shoes won't creep, but I can also bend my foot.
That's not going to work.
Yes, it is.
You go for your plan, Micah. Guys, listen up. This whole page, we're going to let you do alone. So we want individual work. You're doing 2 things. You are rewriting the expression. Okay? So rewrite it in shorter form. And you're going to solve. So I want to know what it equals. So rewrite it in another form. Solve it. This one. Write each expression in exponential. That's changing it from the standard. We haven't talked about this. Let's add this to our paper today, guys. Expanded form. You guys should be writing this down. We're writing another definition. Expanded form is writing a power as a product of its factors. Or in other words, say I have 5 to the 4th power. Expanded form is 5 times 5 times 5 times 5. So this is the expanded form. Make sense? So you're not only writing it in the additional form they're telling you, you're also solving it. Okay? So for the first ones, you're rewriting all these additions. Rewrite all the additions. Okay? You have 8 minutes. Go. Okay. Recording's going. Okay, the first one. Who rewrote this one for me? What do I write that as? Madison. How did you rewrite that one? Yeah, the one with all the 4s.
You're dumb, Aaron.
It's 40. Oh, I just put 40.
How did you rewrite it? You're supposed to rewrite them all.
4 times 10.
4 times 10. Good. Anybody else have something different?
Yeah, that's 4 to the power of 10.
4 to the power of 10. Thank you. 4 to the power of 10. Any other ways we rewrite this?
No.
Don't point at me.
You didn't do it as 4 times 10?
No, I'm so good. It's just like, he's saying 4 to the power of 10. It's like 4 times.
Aaron? You did what? I got that one. Lasena. 10 times 4? Anybody else have something different? Okay, unfortunately, there is only one correct answer for this. It is not 4 groups of 10. It is not 4 being multiplied 10 times. It is 10 groups of 4, which equals 40. Not to the power of 4, that's multiplying, Jonah.
Why are you evil?
We're not evil, we're making sure you understand the difference in notations. Guys, please be quiet. We only have 6 minutes left. We still have to get through all of this. Okay, now that being said, hopefully you guys can do better on the next one. Micah? Would it be 5 groups of 9? Yes. 5 groups of 9 or 45. The next one would be 5 groups of 10 or 50. Guys, please quiet down. Seriously, stop. On our next one, now we're back to the exponential. But we wanted to make sure you understand repeated addition is multiplication. Repeated multiplication is exponents. Okay? Don't get those confused. So now we're writing it in exponential form. So this one is just 5. And there are 5 of them. So 5 to the 5th power. But we also told you to solve it. So when you solved it, this was what? 125 times 25 gives us 25, 10, 12, 11, 0, 10, 4, 5. Should have been 36, 25. I went fast. I didn't make an error, did I? Okay, our next one, 2 to the 4th power. 2 times 2 is 4, times 2 is 8, times 2 is 16. Now we're writing it in expanded form. So this one comes out as 8 times 8 times 8. That should have been written down there. When I multiply that out, 64 times 8 gives us 32, 48, 512. Our last one, 10 to the 6th power, 10 times 10 times 10 times 10 times 10 times 10. Really quick, easy way for you guys. Heads up, because you'll be using this in science. When you use a scientific notation, when I have a 10, a base of 10, and I want to know what it equals, all I have to do is write down a 1, and then I write 1 0 for every number in the exponent. So 6 zeros. And then I can add in my commas. The answer is 1 million. Guys, listen up. How did we do on this? Let's do a quick thumb meter. Okay, so it looks like we're doing better. Good. Okay, turn to page 16. Oops, I forgot to erase that one. I know. We've already talked about the homework, so we can go to the bell. Guys, we can also do exponents with numbers that are fractions or decimals. If I'm using a fraction and an exponent, to make it exponential, what we normally do is we put it in parentheses. So to write this one in exponential form, I just write the 1/2, put it in parentheses. How many 1/2s do I have? 3. So I put that to the 3rd power. To actually solve it, all I do is multiply. When I multiply fractions, what is the rule? How do I multiply fractions? How do I get the answer? Madison? Straight across. 1 times 1 times 1 is 1. 2 times 2 is 4. 4 times 2 is 8. It's that easy. Now, if I have a fraction that's in exponential notation and I want to solve it, I highly, highly, highly recommend rewriting it in standard form, guys. So 2 to the 2/3 to the second power is equivalent to 2/3 times 2/3. To find the answer, all I do now is multiply it. 2 times 2 is 4. 3 times 3 is 9. Emma?
For exponent. So you're multiplying 2 times 3 times 3 is.
Okay, let's look at this last one real quick. So we've given you an example written in exponential form, written in expanded form, and standard form. Standard form is the same as saying what does it equal. Okay? You have 2 minutes. Finish the table. Okay, so for those of you at home, just to finish this up, kids have all been released, but this is easy. So we have 1, 2, 3, 4, 5, 6. That's 2 to the 6th power. Multiplying out, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. 4 to the 5th power, we rewrite that one. 4 times 4 times 4 times 4 times 4 times 4. The easy way to do this is 16, 16, and 4, or you could do 64 times 16. I will probably do 64 times 16, just to make it easier. Gives us 24, 36, 38. 64 gives us 4 to 1,024. And 3/4 times 3/4, so exponential form, we do put that in parentheses since it is a fraction. Then I just multiplied. 3 times 3 is 9. 4 times 4 is 16. And then if it's a decimal, we can just write the decimal and the exponent. This is just so everybody understands why. I'll write it out here. We do 2 decimal places. So 25, carry the 2 is a 7. 0, 5, 1 gives us 5, 2, 2. And I put 2 decimal places in it, so 2 and 25/100ths. So there's your answer to that part. Again, the homework, just make sure you're showing your work. It should be relatively easy, though, because all you're doing is going standard form to exponents and vice versa. Good luck, guys.